in this video here, I will try to give you a sense of what's going on when we say this thing, when one thing is inversely proportional to another thing. How does this thing here compare with this thing here? What does it mean just to have a two in there? Okay, so first draw a graph of what's going on here. So this red line here is represented by this, and the blue line here is a graph of y equals 1 over x squared, and the green line here is this one here. Now the red line, you can imagine it as one person, the time it takes for one person to dig a hole. So let's say one person takes 1 hour to dig a hole. If two people working on the same project, it would take half of an hour. So as you increase the number of people digging this hole here, the time decreases. So you can imagine this graph as being like this. Hang on. You can imagine this. Well, in the red scenario here, y represents time. Okay, the time it takes to dig a hole, and the x here represents the number of people. So in this case, the x-axis here would represent number of people. Okay, represents people, and the y-axis here represents time, the time it takes to dig that hole. Now let's just say it takes 1 hour for one person to dig a hole. So one person here, it takes 1 hour. Okay, suppose you have two people working on that, then two people here, it would take half of an hour. Okay, suppose you have, let's say, 4 people working on that hole, it would take a quarter of an hour. Okay, and the blue line here, this line here, well, you can imagine as you taking a die and a stone to into space. The force that exists between these two objects, well, the force that exists between these objects is is inversely proportional to the square of the distance that separates them. So here, well, I've done several videos on this, so if you don't understand this bit, then watch some of the early videos. So here, in this case, y here, it represents the force. Okay, so the force that exists between them, and the distance, the x here represents a distance that separates them. So here, the y-axis would represent force, and the x-axis here would represent distance. Okay, this distance here. Now, let's just say at distance 1, whatever 1 is, 1 meter, whatever, the force is, let's say 1 whatever. Okay, now if you double the distance, here, the force here, remember, you've got to look at the blue line, because we are looking at one thing is inversely proportional to the square of another thing. So when you double the distance, you see when it was 1, the force is 1, but when you double the distance, it goes up. It decreases by 4. So you can see that with the blue line, it decreases a lot faster than the red line here. Now, if you have a relationship where y is inversely proportional to x cubed, then you can see that this thing here, the green line, it decreases a lot faster than the blue line here. It decreases a lot faster than the blue and the red line. Okay, if you happen to have a relationship where you have something like 1 over x to the power 4, you can see that it will decrease even faster than all the other lines. Okay, so it gives you a sense of what's going on here, and notice that it always goes through 1 here. When 1 is here, this is always 1, because if you plot a line of 1 over x, if you put 1 into the x, it will be 1 over x. Now, if you try and look at 1 over x squared here, if you put 1 into this x here, then 1 over 1 squared will be 1. So it'd be 1 over 1. If you try and investigate y equals 1 over x to the power of, let's say, 7, then when you put 1 into this x, it will be 1 over 1 to the power of 7. Well, 1 over 1 to the power of 7 is 1, so it's always 1. Okay, and if you're trying to investigate y equals 1 over, let's say, x to the power of 5 here. Now, as x increases, so when you make x really big, so if you put a really big number in here, let's say 999 into the x here, well well okay, yeah, put a really big number into the x there. It would be 999 to the power of 5. You see, this number here will be massive. So you will in effect have something like this: y equals 1 over a massive number here. Now, when this bottom number is really big, this whole thing here is really small. So what's happening is that as you go to the right, as x increases and gets really big, then the y value will get really small. It will get really small. No matter what you look at. If you look at y equals 1 over x, or y equals 1 over x to the power of, let's say, 95 here, as x gets really big, then the overall thing here will get really small. That's why you can see that all these graphs uh, head heads towards zero, but it doesn't actually get to zero. I've done a section on this on graphs. Look under graphs, and you can see why. And also, as you get less than zero, it will increase. This is a weird thing. You got to look at you got to watch my well, you got to look at the graph section. I gave an explanation of why as x gets less than zero, less than one, this thing goes up, and there's a reason why. You got to investigate for yourself. Okay, look under the graph section.